Good morning. I'm here today to do a read aloud of the notes on cycles of matter. Sometimes when we talk about cycles, sometimes we refer to them as the cycles of matter or biogeochemical cycles. But we're basically going to be covering the topic of the water cycle, the carbon cycle, and the nitrogen cycle over the next couple minutes. So we usually use this as an introductory question as to what is a cycle. So in your context, you think of some cycle that constantly is going around, or it's in a circle, it's repeating itself. That's kind of what these are. These are but found in nature. Okay, so a cycle is a series of things that can repeat over and over and over again. How old is this water? Take a good long look at this glass of water. So if you just look at a glass of water, how old is it? Is it, from the tap? Does that mean it was, 10 minutes ago? Or is it really, really old? We're going to answer that question. So the first cycle that we're going to talk about today is the water cycle. The water cycle is the continuous process by which water moves from the Earth's surface to the atmosphere up in the sky and back again. And it's constantly being cycled around or recycled around. The four major processes that make up the water cycle include evaporation, transpiration, condensation, and precipitation. Now, sometimes you might hear of the word runoff or infiltration, and there are also other words, but we're going to go with those four basic ones. So if you look here, right on your slide there is a brain pop that links you directly to the water cycle. Again, I know personally I'm a very visual learner, so by watching the brain pop, it's going to kind of introduce to you the ins and outs of the water cycle. Okay, so you can either do your notes first and then come back to it, but it's a pretty short little video clip. I think about 4 minutes, so you can watch that as well. Continuing with the water cycle, let's talk about each type of the water cycle. So we're going to start out with evaporation. Evaporation is the process by which molecules of liquid water absorb energy and change to the gaseous state. So you usually see when you read of evaporation, it's from a body of water. So you can see here, this is kind of like a little lake. It could be from the ocean, any body of water where you can see the liquid a lot of times, and then it will go up into the gaseous state. Okay, so usually on the groundwater and up. Transpiration is probably a new word or vocabulary term for you. Transpiration is basically evaporation, but specifically of plants. You know by now that plants need water, so there's always going to be water found, for the most part, in plants if it's alive. And some of that moisture actually gets lost. So transpiration is the process by which plants lose water out of their leaves. Transpiration gives evaporation a bit of a hand in getting the water vapor back up into the air. Okay, so both evaporation, transpiration, they're kind of go hand in hand like peanut butter and jelly, but one is from a body of water, the other is from plants. Next is condensation. Condensation is the process by which a gas changes to a liquid. Okay, so you're going from gas to liquid. So before we went from a liquid to a gas, now we're going from gas to liquid. You can see these two examples. You can see you have a cold glass, and if it's warmer outside of the glass, which a lot of times if you're drinking an ice cold beverage, a lot of times the outside temperature is a little bit warmer, you'll see condensation on that glass. Okay, so that's an example of condensation. And sometimes if you think about literally in our atmosphere, it's the process of forming clouds. And then lastly is precipitation. As more water vapor condenses, okay, it gets heavier and heavier. The drops of water in the cloud grow larger and heavier, which will eventually, think about whenever it rains, thunderstorms, or has a heavy downpour, you look up in the sky, you see all these rain clouds, right? Because if the condensation, if there's enough water in those clouds, they eventually have to, because of gravity, they have to drop that water. Okay, so that's precipitation. And typically the most common is going to be rain, but there are other kinds of precipitation depending on the atmospheric temperature. So what are the forms of precipitation? You have rain, hail, sleet, and snow. Obviously, like I said, rain is probably the most common. And then sometimes you'll have the snow if it's cold enough below 32 degrees. And then the hail and the sleet, that's kind of the in between, depending on the atmosphere and the layers of atmosphere, what temperature it may be. Okay, kind of when does it change over? So this is an overview of the water cycle. Again, you can see over here you have evaporation and transpiration, which forms condensation, okay, forming clouds, and then eventually it's going to be precipitation. So the clouds will get so heavy that they'll need to release that water as a liquid. You also see some terms, like I said, that I mentioned before, runoff. That's basically from, the precipitation step. You have something called infiltration, which basically is the water going into the land. And then we could start the whole process over again. So it's a constant cycle. It goes around and around. And we're going to revisit that question. Was how old is that glass of water that you just got from the tap, 10 minutes ago? It's not 10 minutes old. It's actually as old as Earth is, and that's 4.5 billion years old. The water that we have, the water that we drink, it's been here on Earth. It's just recycled into many different forms. Some of you guys might think that's cool. Some of you guys might think that's gross, but it's the reality. Okay, so water is as old as Earth. So the next cycle we're going to talk about is the carbon and oxygen cycle. Both carbon and oxygen, they're necessary for life. A lot of times you'll hear us talk about the carbon cycle, and we're basically talking about how does the CO2 and O2, which is carbon dioxide and oxygen, how is it exchanged between plants and animals? So that's kind of the big picture question. In a couple days, you're actually going to be talking more specifically about photosynthesis and cellular respiration, which is kind of an important point that you'll be learning about coming up next. But for right now, carbon and oxygen cycle is basically, you should know by now that as humans, we intake oxygen or O2 and we release CO2. Plants, on the other hand, take in CO2 and release oxygen. Okay, so your producers or your plants take in that CO2 during photosynthesis, and then the oxygen is released as a waste product of photosynthesis. And then most organisms like you and I, we need that oxygen to survive, from plants to carry out the respiration, the step of respiration. Okay, so we kind of need each other. That's why I say, why is it such a big deal when you're cutting down trees? Well, they're kind of our byproducts of getting that oxygen to us, right? So we kind of have to think about our environment and kind of how we take care of our planet. So if you look here, you will see another brain pop, which is on basically the carbon cycle. It also talks specifically, which we'll talk about too, the byproducts of methane gas. Methane gas is kind of like a pollution byproduct. So kind of how does that cycle in, and how can we prevent that and stuff like that. So that's your brain pop on the carbon cycle, okay, and how it gets recycled. And then lastly, the last cycle, which is probably the most complicated of them all, is the nitrogen cycle. And what you guys need to know is this. Nitrogen, believe it or not, is the most abundant gas that we breathe in every second of every day, but it's not usable. It's not a usable form to us. So we have to get it through another means. And we kind of depend on a lot of other organisms to help us with that process. So like carbon, nitrogen is a necessary building block in the materials that make up living things. Nitrogen is a building block of our base pairs, which make up our DNA. So nitrogen is kind of a pretty big deal. But like I said, the element nitrogen in the air, it's not usable to us. The nitrogen gas is not usable to us. So we take it in, it doesn't harm us, and we breathe it out, but no big deal. So we have to depend on these organisms that are going to be, quote unquote, fixing that nitrogen, so that we can ingest in our diet different byproducts that we can consume, that we can absorb it into a usable form. Okay, so it has been fixed or combined with other elements to form nitrogen-containing compounds. I love this visual. If you type in Google the nitrogen cycle, this is one of the most common graphics that actually pop up because it is so great. You can see all this N2, which is your atmospheric nitrogen, okay, completely useless, right? But there's all these other things that kind of help us with the process. So there's nitrogen-fixing bacteria that lives on the legumes, which legumes are beans, that bacteria can fix it for us so that when we consume them in our diet, it's a usable form. Otherwise, there's bacteria in our soil that are constantly being fixing that bacteria as well. It's through the process of nitrification. So they change it into the form you can see N2, NO2 with a minus, and NO3 with a minus that deals with the ions. And then it will be found in plants. So then plants can absorb it. And then once you eat plants, then you can absorb that nitrogen into a usable form. Decomposers are a huge part or a huge component of this as well with the nitrogen cycle because they're going to help the bacteria. Okay, so everything is kind of interconnected. And this is just a review. These nitrogen-containing compounds are fixed by bacteria and legume root nodules. Nodules, I think of them as like little warts on the bean or in the legumes roots, and through nitrogen-fixing bacteria in the soil. So between all of those kind of components, we can kind of get the nitrogen that we need. So nitrogen in the air becomes part of a biological matter, mostly through the actions of bacteria and algae in the process known as nitrogen fixation. So it doesn't matter how you get it as long as you get it. And then decomposers break down the complex compounds in animals' waste and the bodies of dead organisms. That's kind of what decomposers do. At some point, bacteria break down the nitrogen completely, and then this releases the free nitrogen back into the air. So again, everything is cycled through. So then that bacteria will then release that atmospheric the N2 back into the air, even though we don't need it. And I think that might be it. So that was an overview of our read aloud notes on the cycles of matter. The big ticket ideas are this. The water cycle, the carbon and oxygen cycle, and the nitrogen cycle. No, it's a cycle, okay? It's not like you can just create carbon or you can't just create nitrogen, right? It's there. It's just how is our environment kind of using it and recycling it into different forms. Okay, if you have any questions, please feel free to reach out to your science teachers. Otherwise, have a great day.